Hi everyone, welcome to the Mooncamp webinar. My name is Nina and I'm part of the ESA Education Office and I'll be your host today. And I'm very happy that we have here James Carpenter, who is head of the ESA Lunar Science Office. And so before we begin, James, how are you feeling?
Very good. Looking forward to this webinar today.
Great.
Yeah.
So before we begin, I would like to highlight that Mooncamp is organized by ESA in collaboration with the Airbus Foundation, Azeros, and national partners. And we're very happy that already over 400 students have submitted a project today, and we're sure that many more are in the making. So we're looking forward to those. During this webinar, James will take us on a fascinating journey through some of the highlights of lunar exploration. We'll be answering your questions and we'll be showcasing some of the projects that have already been submitted. So, and afterwards at the end, there's a possibility to ask additional questions. So if you have a question, please make sure to use the Q&A feature on the top of your screen to send us any questions you might have. And we'll be answering those at the end. So, James, before we dive into lunar exploration, could you tell us a little bit about what you do at ESA?
Very good. So I'm the head of the Lunar Science Office, which is part of the Directorate of the Human and Robotic Exploration. So our program is about sending humans and robots to the locations in space where humans may one day live and work. So that's low Earth orbit with the ISS, International Space Station, going on to the moon and then outwards to Mars as well. And my team is responsible for all of the scientific research that we do at the moon. So that's research to understand the moon, understand our place in the universe, but also to understand how we can explore better in the future.
Wow, great. That sounds like an amazing job.
Cool.
So the topic of this webinar is called Back to the Moon, Shaping the Future of Lunar Exploration. Could I give you the clicker and tell us a little bit more about that?
Very good, thank you. So what I'd like to do today is to give you a flying tour of the moon. I'd like to tell you something about where it comes from, what it means for us, what it can tell us about our place in the universe, but also about the work that we're doing to understand how to explore more in the future and to give you some idea of what maybe is to come in the decades beyond and the kind of things that you might be working on not too many years from now. So I'd like to start perhaps by showing you the moon as we see it. This is an image that was created using multiple images produced by a spacecraft called the Lunar Reconnaissance Orbiter and a camera on that. And it's made up of each individual pixel in this image is 100 meters across. And as we rotate the moon, you can see that the near side and the far side are very different from each other. So the far side that we can't see from Earth looks very, very different. It's paler, it's much higher, and it's much, much older. So the universe, the moon was formed billions of years ago by a massive impact of a body about the size of Mars with the Earth. And since then, the moon has come together and it's formed. The crust, the pale stuff that we see, formed, and then magma from deep inside started to erupt onto the surface. But since then, it hasn't changed very much. Now, what's important about that is while on Earth, we have earthquakes and volcanoes and wind and rain and weathering that has transformed the surface of our planet, the moon's surface is very, very ancient. It has barely changed in billions of years. And for that reason, it records the history of the entire inner solar system, including the very early Earth around the time when life was first forming. And so by going to the moon, we can understand how all of the planets formed, and we can understand some of the things that happened in the early Earth that we can only discover by going to the moon. One of the things that we need to do when we get there is to understand how we're going to explore in the future. Now, something that has always driven human exploration is the search for resources. And we now know from images like the one that I just showed you, which have only been available for a very few years, that there are resources that we could use on the surface of the moon. What you see in this picture is an image of places where we might find ice near the south pole of the moon. And ice is water. Water is important for human survival. It's also a source of oxygen and hydrogen, which together make rocket fuel. And so water ice that we could find at the moon is one of the examples of something that we could use to help us to explore more in the future. So we're looking, one of the things we're going to do, and we are starting to do, is to look for potential resources on the moon. And something that's very important for us in ESA is to understand how, if we ever use those resources in the future, how would we do it in a responsible way where we know that we're looking after the environment that we find there, and making sure we're careful about being responsible for that for future generations.
Can I ask you a question about the
Absolutely.
previous slide? So we saw these very nice shades of blue. Is this something that we would see with our own eyes, or is this something?
So this is very important, actually. So what I'm showing you here is not a real image. What we've actually done is we've measured the temperature at the surface from orbit around the moon. And based on the temperature, we can work out where we might find water. And so what we've shown you in this image, it's a picture where we have the moon, and on top of that, with colours, we have shown where water might exist. So where you see it in very light blue, this is where water could exist just at the surface. And where you go to the more pinky colours, this is about 1 metre beneath the surface. So what that shows us is, in some places, it's very, very cold. Some of the coldest places in the solar system, and water ice might be right there. We could touch it as frost. But in some places, we need to dig a little bit to get down to find it. And actually, a really important thing for us as we explore is the places that are really cold, where the water ice is easy to get, are the hardest places to get to for us because they're the darkest and the coldest. And so we might need to dig a little bit to get some of these things, but that's the kind of information we need to find out. And maps like this are a way that we can show that information so that we can understand better what we need to do.
Great, thank you.
Thank you. And actually, with that in mind, I'd like to show you a video of a mission that we are preparing called Prospect. And Prospect will go to one of these locations where we need to dig a little bit beneath the surface. So this is a video that's made by a company called Leonardo. Leonardo are based in Italy, working with the Open University in the UK to build this for us. So this is a video that was taken inside a chamber on Earth, which simulates the surface of the moon. And Prospect, we can see here, drilling into the surface, taking samples, and then delivering those samples robotically into a laboratory. These samples are then analysed chemically to understand what they contain and to show how we might be able to extract water and other potential resources out of those samples. So this is a really important step for us to understand what's there, but also to test some of the ways that we might use in the future to access and extract some of these potential resources.
Okay. And so why do we need such a special drill machinery to do this? Would it be also possible if, for example, I take a drill from my shed and go to the moon to extract it? What's so different about the soil there?
So building things to work in space is always very difficult. So we're there in a very, very difficult environment. We're operating completely robotically. So we have to build all the robotic systems and the computers to be able to do that. We're also drilling into an environment which is very, very cold. So as we drill beneath the surface, we're trying to extract ice, which is very, very cold, and there's also no air. And one of the things that happens is as you expose water ice to an environment where there's no air, the water ice will tend to just sublime. It turns straight into gas and comes off. And so we also need to design it very carefully so that we can control and understand the temperature of the samples so that we can preserve what we're trying to measure. So this has actually been a very, very complicated thing to build. If you see it in real life, it's really very big, but it's very, very difficult to drill on the moon. During Apollo, I had the privilege of meeting a man called Jack Schmitt. Jack Schmitt is the only scientist to have ever been to the moon. He had experience of drilling with a hand drill in Taurus Littrow on the moon, and he reported that it was very, very difficult to do. So this is a very challenging mission for us, but something it's the first time that this is the most complex package I think that's ever been sent to the moon to do anything like this.
Great, fascinating.
So I talked earlier on also about the importance of the environment. So one thing we want to do is to understand the environment so that as we're operating, as we're building things, we understand what it means to operate in that place with the conditions that we find. We also know that human activity will forever change the environment that we find on the moon. That's almost impossible to avoid. And so we want to make sure that, first of all, we understand what it's like. Secondly, that we can monitor the changes that happen as humans explore. And third, that we can create ways of being as careful as we can, as responsive as we can with that. What this image shows you are some of the things that drive that environment, that make it the way that it is. So the sun is throwing out radiation all the time. That radiation called the solar wind, and the solar wind hits the surface of the moon along with other radiation from the sun, what we call ultraviolet. And that radiation has an effect on the surface of the moon. It causes dust to rise up. It causes electric charging to happen. And this creates a very difficult environment to operate in, and something which is complicated and we're trying to understand. And our first project to go to the moon to understand this environment from ESA was something called the negative ions at the lunar surface experiment. So that's looking at one particular population of or kind of particle that we would find there. And this is a picture of it attached to the Chinese Chang'e 6 mission. Chang'e 6 went to the moon in June of this year. It operated very briefly, took samples, and then returned those samples to Earth. And we were attached to the side of that, the lander on that mission, and operated there for a few hours on the surface of the moon.
And can you tell us a little bit about the importance of these type of international corporations?
Well, international partnerships are really a fundamental way that we do many of our projects. It's also one of the reasons why we do it. So in Europe and in ESA, we explore to learn more about the universe for science. We do it to drive our technologies, to help us to build better technologies, more advanced technologies. We do it to inspire, to give people something wonderful to enjoy and to aspire to and to be inspired by. But also, it's a way of engaging internationally. It's a way for us in Europe to work with other countries around the world and to work together. And so in this case, we were working with China. We do a lot of work with many other countries, and particularly with the United States and with others as well. And finally, as I mentioned earlier, the moon is a unique location for science. So the moon is fundamentally interesting. It's an extremely important body in that it tells us about the history of the universe, the history of the solar system, the history of our own planet. It's also important as a unique location to stare out into space. So this is not a real image. It is a visualization of what it might look like if you looked at the sky in radio from the lunar far side. So the radio waves are coming back from outer space all the time. And those radio waves come from planets. They come from stars. They also come from deep back in time. So if you want to look back to the earliest part of the history of the universe, you have to do that looking into radio and microwave. And so the radio waves that come from this earliest part of the universe actually are impossible to see from Earth. And part of the reason for that is that Earth is very noisy in radio. Earth puts out a lot of radio. And the only place in the solar system that you can't see the Earth in radio is the far side of the moon. And so one of the things that we would be interested in doing in the future is to observe the solar system, the universe from the far side of the moon. And so that's an example of how the moon is, I think, will become in the future a unique place where we do scientific observations. And a first project that we're working in to do that is a cooperation between ESA, the United States in NASA, and also the Department of Energy, which is another part of the US government, for something called Lucy Night and Pathfinder. So Pathfinder comes from ESA. It's the spacecraft you see on the left side of this image. And Pathfinder is a spacecraft that will take communication signals from the far side of the moon, where we can't see Earth, and transmit them back to Earth. And it's going to provide that for a spacecraft, the lander on the surface called Lucy Night. And Lucy Night will have the first ever instrument to measure radio on the lunar far side. We won't be able to look into the the earliest epochs of the universe with this instrument, but it is going to tell us what it's like on the far side of the moon so that we can do that later on in future missions.
And it's called Lucy Night. So does that mean it's only observed during the night?
It's called Lucy Night because there is another mission which we're not involved with called Lucy. And Lucy is a very short mission and it will only last during one lunar day and it's not on the far side. So it's called Lucy Night because something which is unique here, a first time, is it's going to operate through the lunar night. One of the big problems, big challenges that we have building anything for the moon is that the day-night cycle on the moon is very long. So we have 2 weeks of daylight followed by 2 weeks of night. And during those 2 weeks of night, it's incredibly cold and it's very dark. And so we can't get solar power for energy. And so if we want to stay alive in that cold condition, we have to find another way of getting energy. And that means taking, at the moment, either batteries or certain kind of nuclear power source. And we don't use nuclear power sources very much today, though we probably will do in the future. So the only solution at the moment is to take a really, really big battery with you. And that's very expensive to do. But this is what this mission is doing. It's taking a very large battery to allow it to operate through the lunar night. And as we look onwards into the future, what we're going to find is that the moon becomes an outpost for humanity. So the moon today is Antarctica 100 years ago. So what we're going to see within not many years from now is the beginnings of infrastructure on the moon, of robotic and eventually human bases on the moon for doing science and technology and other things too. And on this image, what you see is an artist's impression of what that might look like. The important thing here for us is the lander that you see here is called Argonaut. Argonaut is a lander that we in ESA are developing. And that's going to be Europe's lander to get European science and technology to the surface of the moon, and also something we can use to cooperate with our international partners as we do this together. And a first step for us on the way to this sort of longer term vision is Gateway. So Gateway is humanity's first outpost near the moon. It's an orbiting outpost, a small space station, a staging post to get to the lunar surface. The first lunar lander missions will go from this outpost. The Orion vehicle, which you see here on the bottom left of the image, has the back end of that is produced by ESA as a contribution, and some of the habitats, the modules in this space station are also being developed by ESA.
So is this comparable to the International Space Station in size?
It is much, much smaller. So the International Space Station is enormous. This will be very, very small by comparison. So if the International Space Station is a mansion, this is a Winnebago. This is a camper van. It's a very small vehicle by comparison. Humans will go there for fairly short periods of time, so tens of days rather than tens of months, which happens on the International Space Station. And they'll be there during the period while the crew go down to the surface and then back up again.
Okay. And so another question is, are we going back to the moon to stay this time, or will it be again a shorter period of time like the Apollo program?
I think we are going back to the moon to stay. So the moon it's a continent. It's a continent about the size of Africa. It's just quite difficult to get there. But it is just another continent. It's another place. And once we've learned to sail there, we are going to learn how to use it. We're going to learn how to benefit from it. It's somewhere where we can learn to work together as humanity. It's somewhere we can do science together. It's also a place where we're going to learn how to live and work off Earth. And as humanity moves out into the solar system, and we will, this is where we're going to learn how to do that. And so what's going to happen in the next few years, I think, is of really fundamental importance. What we're doing right now is establishing the basis for permanent human presence beyond Earth. And I think that is the most extraordinary thing to be involved with, and something that I think many of the people watching this now will have the chance to be involved with too, if that's something they would like to do.
Yeah, for sure. I think, this is super inspiring for them as well.
Cool. Yeah. And finally, just to finish, this is an image that was taken some years ago by the Lunar Reconnaissance Orbiter. It was a Christmas present to the world from the Lunar Reconnaissance Orbiter team. It's a very, very high resolution image of the Earth as seen from the moon. And I think the thing that the first era of lunar exploration taught us when we went to the moon, and this image was taken for the first time during Apollo, is that the thing that we discover as we explore the moon is actually we discover ourselves. We discover our own place in the universe, and we see ourselves in a way that we can't in any other way. And so I think that this is a beautiful, an optimistic view of the future, and something that we can realize, and I think is at the core of what ESA is about.
For sure. So thank you for this incredible story. I think this is super inspiring, and I see for sure how the people at home can see themselves also in this picture in the future. So thank you for that.
Thanks.
And so I think now we can continue to the next part of this webinar. We have a few questions for you from the people at home that they've submitted. So if it's okay for you, I'm going to start with the first question, and if I could get the clicker, thank you. So the first question is actually a set of questions. So I will read them out together to you, and then I hope you can answer them in like one go. So the first question is from Team Astrowalkers from Greece. Was it your dream to become an astrophysicist and planetary scientist when you were a little kid? And then the second question, and I hope I pronounced this correctly, from Școala Gimnazială George Voivodca from Romania. What inspired you to pursue a career in lunar science, and what motivated you to join ESA?
Okay. So as a child, I was fascinated by space. I was very interested in it. It never even occurred to me that it was a career choice. So I didn't dream of becoming an astrophysicist or a physicist or a planetary scientist, because I didn't know that such things existed or that it was really something you could do. I was probably 16 when I realized that that was really a career path, that existed. When I realized that there were people in Europe that built things that went to space. And once I knew that, then I knew that that was what I was going to do. And there was no option the other way. For lunar science specifically, I never chose to be a lunar scientist. I worked on building instruments to go to other planets. I worked on Bepi Colombo and some things on the International Space Station. I started working, I'm a physicist. I started working with geologists who know about planets, and because we were building instruments to look down at them. And over time, I found myself more and more working on lunar related topics, especially as we in ESA started growing our lunar activities. It was something that I became more and more involved with, and now it's become a major part of my life in ways that I had never predicted.
Yeah, so you kind of went from one thing to the other, and slowly you started getting into this. Wow, great. Thank you for that. So yeah, the next question, maybe maybe it's a very nice one to continue on this topic. So this one is from Team Agrupamento de Afonso 3 from Portugal. What makes the moon so fascinating to you?
I think what makes the moon fascinating to me is the science that I talked about, the fact that it's an archive of the whole of solar system history. But more for me, it's not what it tells us about the past, but what it tells us about the future. I think that there is an opportunity as we reach out into space together to do things in a new way. I think that as we explore space, all of humanity is going to benefit from this. I think that the moon is where we go to learn how to explore. It's where we go to learn how to use the resources of space, and where we go to learn how to do this together. And I think the moon, so that's what it means to me. It's a story of hope for all of us, which I think is wonderful. And one of the things I think is great about ESA is that ESA has international cooperation and peaceful exploration at its heart. And I think that's something which is really unique to Europe and unique to ESA, and something that is important for us.
Yeah, that's great. And I think maybe a follow-up question on that, because the moon is super fascinating, but hope if it clicks. Yes. So, yeah, a follow-up question to also your team. What are the biggest challenges your team is facing in advancing lunar science? And this question is from Team Benedictus from Lithuania.
So there are technical challenges. So getting to the moon is hard. Staying alive on the moon is hard for your instruments and your systems because it's a challenging environment. You have these 2 weeks of cold and darkness. Some of the most interesting places for science are some of the hardest to get to. So there's the technical challenges. There's also the challenge that we have limited resources. There is limited money to do these things, so we have to be very selective about what we want to do and how we do it. And so trying to find how do we use the resources we have in the best way possible to deliver the best science that we can and to achieve the most significant outcomes. I think that's a difficult thing to do. And also, I'd say working with lots and lots of countries. Having lots and lots of countries working together is really hard. But I also think it's brilliant. There's no one in the world except the European Space Agency that can do that in the way that we do. And I think that's difficult and it's challenging. But it's also, I think, one of the wonderful things about working here.
Yeah, you get a lot of different views into one project, which is amazing, right. Of course. Yeah. And so when we look at the moon, do you already know what we're going to explore next? And this specific question came from 5 Deliria Go, de Stappenstaafbroek from Belgium. Okay. Which planet will be next to explore after Moon and Mars?
So I think we can talk two things, like human exploration, robotic exploration. Yeah. So in our program, exploration program, we're looking at places where humans might one day live and work. So we're looking at low Earth orbit, the moon and Mars. We already have robotic missions in orbit around Mars. We're developing missions to go to the surface of Mars. We're looking at robotic and human missions to go to the moon. But we are already exploring other parts of the solar system robotically. So we have the Bepi-Colombo mission that's going to Mercury, which has passed Mercury several times. We'll be there in orbit soon. We're developing now a Venus mission. We have the JUICE mission that's going out to Jupiter. So there are lots and lots of missions within ESA and even more missions around the world that are exploring beyond. So I think for now, getting humans to Mars is already pretty ambitious. I think I will see that happen, but it's still very difficult to do. If we think going beyond Mars, I think you could use your imagination. I think asteroids would be a great place to go. I think the moons of Jupiter would be my favorite places to go, but there are some big, big challenges to getting people there.
Mm-hmm. So that will take a few more years.
It'll take a while.
Yeah. But perhaps something that the audience watching will be involved in.
Perhaps, yes.
Yeah. Okay, thank you very much for your answers to all these questions. We'll be answering a few more at the end of the webinar. But for this next item, we would like to show you a few of the projects that have already been submitted to us from a few teams. So I will show you them. I will read out a little description and we would like to hear what you think of them.
Very good.
So we start with the first one, which is from Team Artemis. And Team Artemis has created a base on the moon using recycled materials. Their project includes research on possible suitable locations on the moon. And based on the research, they concluded that Shackleton crater, located on the moon's south pole, has the most potential as it possibly contains frozen water beneath its surface.
So very good. So let's talk about Shackleton. Let's talk about recycling. So as we explore the moon, Shackleton crater, or the rim of Shackleton crater, is really interesting. So there are very, very few places on the moon where the sun almost never sets. So the moon's like a big ball, it's rotating and the sun essentially goes around it like this. You would see it go around. If you're at the poles of the moon, the sun kind of goes around you like this and it almost never sets. Every now and then it will duck behind a mountain. But that does mean that this thing I talked about earlier with these 2 weeks of darkness, you can avoid that and you can use solar panels to generate energy. Next to that, you have a crater like Shackleton. These are permanently dark. You could have water ice trapped in these places. And so there is a lot of interest in putting missions and potentially lunar bases and things in the kind of these rims around these areas. So you have this wonderful two things together. You have sunlight and you have ice. So it's a great location. And recycling is also something that's really important. I talked earlier about being responsible in how we explore. one of the things that's going to be really important is how do we recycle and repurpose the things that we take with us. And so I think that concept, that idea of recycling what we take is a really powerful one, and something that we're thinking about too.
Great. Thank you for that. And now we go from the moon, we take a little jump towards Mars for the next project. So this project is called the Odyssey Mars mission by the Hungarian Mars explorers. It's designed in Tinkercad and aims for sustainable living and research on Mars. Robots will first go there to locate water and a habitable cave. Their spacecraft features medical and hydroponic systems, while the Mars habitat relies on solar power. The crew will stay for 2 years until the next window between Mars and Earth opens.
So I really like here the way that the whole architecture, the whole story has been thought through. So how do you prepare the way in advance? That's really important. We need to understand where we're going before we go there. I like the idea that you have the medical bay in the spacecraft. One of the real challenges, probably one of the biggest challenges for human missions to Mars, is how you keep humans healthy on that trip. They're going to be exposed to low gravity. They're going to be exposed to radiation in space. They're going to be exposed to isolation in confined spaces. And we don't know yet how to do that, how to make that work. So I think a lot of work is going on to understand what that means, but also in how we look after people, how we keep them healthy for those trips. So the medical bay is really important. We need to feed them. It's a long trip, so hydroponics definitely something important for keeping crew alive and well fed. And the idea of going into a cave for your lunar base is a really good one. Like, getting into a cave is pretty hard, but if you're looking for a place that has some stability, where you're safe or you're shielded from the environmental conditions, a cave is not a bad place to try and go. So a very, very challenging mission, a very challenging architecture, but something that I think is well thought through, and all the pieces are there. It's very good.
Yeah, and they're mentioning that a round trip is taking a lot of time. Could you tell us a little bit about that? Why that takes so long?
Right. So Mars is quite a long way away, but also so it takes around 6 months to get there typically. But when you go, it also depends on so Earth and Mars are going around the sun in different places and at different rates. And so sometimes the locations of Earth and Mars are well aligned and it's a short trip, and sometimes they're very, very far apart. And so after you launch, you have your mission to get there quickly, but then you need to wait until Earth and Mars are aligned again before you come back again. And so that's what takes a long time.
So also humans have to be even more prepared than for going to the moon, probably.
Absolutely. A trip to Mars is it's a multi-year commitment. It's not a short trip. Yeah. And no one's coming to help you, right? So so you need to be secure. You need to know what you're doing. You need to be well set up to look after your crew.
Fascinating. Okay, so lots of things to think about indeed. So now we continue to the last project that we would like to show you, which is actually a video. And while it plays, I will give the introduction. So this is from Team Batterick Wardens from Belgium. They designed a moon camp in Minecraft. It features a steel bunker for protection, a greenhouse with thick glass for crops, an aquarium for research and relaxation, and a dormitory for astronauts to unwind and where they can bring a bit of home with them to the moon.
So firstly, I love that this was done in Minecraft. I think this looks like a wonderful place to be. Actually, one thing I see with this idea is actually has a lot of space for crew well-being. It's somewhere one could imagine crew spending substantial amounts of time. One thing I particularly like actually with the aquarium as a thing for research, if we're looking into how environment affects humans. So one of the things that we want to understand is about microgravity or reduced gravity and how that affects our bodies, but also about radiation. So with these on the moon or on Mars or on the way to Mars, we're in a radiation environment, which is very different from what we would find in low Earth orbit on the space station or on Earth. And so we want to understand that. And actually some kinds of fish are actually a very good analog or a good way of exploring what happens on humans. So sending these fish into these environments and seeing how radiation affects the fish tells us a lot about how it affects us. And so actually an aquarium for research is a great idea.
So are we planning to send up fish also to the moon?
Not at the moment, but I have seen proposals to do that. So it's an idea which is definitely out there. But one thing we are doing is looking at what we can send up as biological materials, biological samples that can be representative of what humans do. So we can, what science can we do into these effects that don't involve us testing on humans? And that's actually an important part of what we're looking into.
Wow. Interesting. Thank you for that. So yeah, we went through all the designs from the team so far. That we took a few from to show here, and I think it's great to see that already these three projects were made in such different ways. So we saw arts and crafts, we saw Tinkercad, we saw Minecraft, and I think that's also one of the nice things about this Mooncamp project is that you can choose your design medium, whatever you like to do. So we are slowly approaching the end of this webinar, and we have received in the meantime some questions in the Q&A, so I would like to read them to you. So the first question is, why are, and I will show them on the screen, why are the moon,
the Mari.
mostly formed on the near side? I would expect more impact on the far side that is not protected by the presence of the Earth in the meteor trajectories.
It's a very, very good question. And the answer is, we don't know. We don't know. It's not clear at all why the moon is the shape it is, why the Mari happened. Mm-hmm. So the Mari tended to have formed inside these basins. You're absolutely right in the question that very large impacts smashed into the lunar surface. They created these large, we call basins, so mm-hmm. very, very big impact craters. And then later on, lava has come up from deep inside the surface and flooded these big craters. Mm-hmm. And that's what causes the Mari, which are the dark patches that you see when you look at the moon. And in the picture I showed earlier, when we rotated the moon, you can see it on the far side, there's almost none of them. Now, one thing we do know is that the thickness of the crust on the near side is much thinner than on the far side. The far side is much thicker, much higher. So that's probably part of the reason. But the truth is we won't really have a great understanding of why the moon has formed in the way that it has. So that's one of the things we want to understand. Yeah. And there's a question on the space station.
Yeah. So, how will you build a lunar space station?
Yeah. So I don't think we know at the moment. One thing that lots of different countries are thinking about are how we would do this. So in ESA, we're thinking about a base camp, what those first elements might look like in building a lunar station. In the US, they talk about Artemis Base Camp as a first infrastructure for short astronaut visits. And in China, they talk about the International Lunar Research Station. So what I think will happen is there'll be a slow build-up originally of robotic elements, so landers and some of the rovers and things we would use, and then over time you'll start to see the build-up of infrastructure. So in Europe for the moment, in Italy, run by the Italian Space Agency, they're starting to work on a pressurized habitat, which would be part of this surface base. So I think we internationally are trying to think about how this would come together, and it's something which we're working out, but the pieces are coming together.
Yeah. And is the plan then to send all the pieces from Earth to there, or will it also be at some point be the case that we can start creating from the resources there?
It's a really good question. At some point, I think we're going to have to start using the things we find in the places we'd go to do things. So if you take a habitat, for example, and you take it from the Earth to the moon, and I think we're going to have to do that, one of the things we need to do is to protect it from radiation. And that's really difficult to do. Ways you can do that are dig a really big hole, put it in the hole, or you can take and you can cover it in lunar material. That's another way of doing it. And so there's a lot of work going on to understand how we could do that, take lunar materials and create things like radiation shielding or structures and other things. So it's probably not going to be the thing we do first, but it's definitely the direction of travel.
Great. So I see we have a last question. Will humans ever permanently live on the moon? Is it really something we need and want? This is asked by a student, and the parent asks, will going to the moon really improve life on Earth in terms of resources, tech development, etc.? If yes, how?
Second question, very good. Okay, so will humans permanently live on the moon? I don't see today a reason why humans would live permanently on the moon. It's possible. So we have permanent human presence in low Earth orbit now. I think at some point it's not unlikely we'll have permanent human presence on the moon in a similar kind of way. I don't expect cities on the moon or anything like that, but I think as we start to, I think it depends on how we start to use the moon. So as a place for doing science, perhaps like in Antarctica, we'll have people go there for stints where they have research missions and then they'll come back. So I can imagine scenarios like that. I can't imagine ever having people living there permanently as their home, perhaps in the far future sometime, but it's not something I would want to do.
But is there a possibility that the moon will be more commercial at some point?
There is a lot of commercial interest in the moon. People want to understand, or companies are interested in understanding, are there things we could do commercially at the moon? I think that at the moment, most of this commercial activity is driven by agencies, by NASA, by ESA as potential customers. So if we want to do something at the moon, we have the option, we could build it ourselves, or we could pay a company to do it, or we could do it on a commercial basis. So we're learning how we do it. You know, how are we going to do this? What's the role for commercialization in this? Is it something we really need and want? I think it is. I think it's something that's wonderful and hopeful. I think it's something that is a big peaceful project for humanity. I think that there is science and technology benefit that we get from it. But I think it ties in with the last question about will going to the moon really improve life on Earth in terms of resources, technology development, etc. So I think the answer is yes. I think that the yes is a different yes depending on when. So in the near term, I think it improves life on Earth as a tool for international cooperation. So it is a way that we can learn to work together internationally. I think that has benefits immediately in terms of just creating peaceful things we're doing together. I think that the science that we learn there is science that we can't do anywhere else. And science always has benefits, sometimes in the longer term, but science always produces benefits as it creates knowledge for us. The challenges we're facing there push technology. So, for example, we have to operate, we need energy. We need energy in an environment which is challenging, which is very constrained and very difficult. And in that environment, it forces us to produce more efficient batteries, other ways of managing power. And I think the lessons that we learn in how we do those things create spin outs into how we do things on Earth. And there's examples of that from what we do on space station, for example, where things we've done there pushing certain technologies have had big implications for the way that some industrial processes run on Earth, for example. So I think that happens. In the longer term, I talk about resources, for example. I don't know if there's a resource on the moon that's going to change life on Earth, but there might be. And we need to be careful if we find that thing about how we do it. And this is where commercial comes in again. We need to be really careful about it. But the first step to prepare is we have to first understand what's there. Once we understand, we can start to create rules about how we do things later. But there are a number of things, and I probably don't have time to go into it now, but there are a number of potential resources on the moon that could have a big effect on life on Earth. We just need to explore more to understand whether that's really a thing or not. So I think the answer is yes. I think there's improvements to life on Earth in the very near term, in the midterm, and in the much longer term. And that's why we explore.
Great. I think that's super inspiring. I have one final question for you before we move to the closing of this webinar. It has been very fascinating so far. So when the next astronaut lands on the moon, where will you be and when will that be?
Where will I be?
Yeah.
Well, I won't be on the moon. I will probably be watching it. I hope that in some way we will be involved in that. We work very closely with the US. I expect that first astronaut will be American.
Mm-hmm.
So I hope that we will be involved somehow. I would like to think that I will be watching it from a privileged position in some way, but I will definitely be watching it.
Yeah, and I think the whole world will be watching,
I think so.
as well as the people from home as well. So thank you very much for all your answers and taking us on this interesting journey. I would just like to mention a few more dates to the teams watching from home. So if you want to participate in MoonCamp, and we hope, of course, you do, that you may be already working on a project, you have until the 28th of April to submit your project. And if you have submitted a valid project, you will receive certificates and an invitation to the next webinar, which will be with an astronaut, and that one will be hosted in May or June. The exact date of that will be announced later, so you will receive more information about that. If you have any questions in the meantime, we advise you to have a look at our website with frequently asked questions. You can find that at mooncampchallenge.org/FAQs. Or you can send us an email to moon.camp@esa.int. So we thank you very much for watching today. We hope it was very interesting. And we also look forward to seeing your projects in the coming months. And James, also thank you for sharing your knowledge and sharing also your time today. Do you have any final message for the teams watching from home?
Just to say that I think it's great that you're all involved in this. I think it's a fantastic opportunity. I've enjoyed very much seeing the outcomes of the work that you've done, the thought and the logic, the thinking, the creativity that's gone into it. And I think that space exploration and space in general are going to be an increasingly important part of our lives. I think there's fantastic opportunities, and I look forward to seeing how some of you are going to affect these and be involved in this in the future. So thank you very much for being here today. I mean, it's been fun to talk to you.
Well said. Thank you for that. So yeah, now it's time to really end this webinar. We hope you have a lovely rest of the day, and we hope to see you next time. Bye-bye.